Suppose you're asked to graph one cycle of the function y equals 2 secant of x over 3 plus pi. Whenever you're graphing a secant or a cosecant function, it's important to first graph the reciprocal function, the either sine or cosine function. In this case, the first thing you want to remember is that secant is the reciprocal of cosine. So we're going to begin by graphing the reciprocal function. Y equals 2 cosine of x over 3 plus pi. Now this will be exactly what you were doing in the last section. The first thing you want to think about is your basic graph of just y equals cosine of x. So remember, you get one cycle for the graph of cosine as x goes from 0 to 2 pi. Cosine of 0 is 1. Cosine of 2 pi is 1. Right in the middle, at pi, the y value dips down to -1. Halfway between that maximum and minimum value, you get an x-intercept at pi over 2. Oops. This. That's why I should graph in pencil. And halfway between this minimum and maximum at 3 pi over 2, you get another x-intercept. So your basic graph of y equals cosine x looks like this. First important thing, we get one cycle as x goes from 0 to 2 pi for cosine of x. For cosine of all of this here, we'll get one cycle as all of that, x over 3 plus pi, goes from 0 to 2 pi. Now we can find the starting and the ending values, starting and ending values for one cycle of this graph by isolating x in this inequality. So I'm going to just subtract pi from each part of the inequality. So I get negative pi is less than or equal to x over 3, less than or equal to pi. And now I just multiply each part by 3 to isolate x. So I'm just going to multiply each part here by 3. So I have negative 3 pi is less than or equal to x, less than or equal to positive 3 pi. So now I have starting and ending values for one cycle of the graph. Now I'm going to start to draw my graph over here. I will switch to pencil now. So let me mark off negative pi, negative 2 pi, and negative 3 pi. And then pi, 2 pi, and 3 pi. I'm going to call this 1 here, -1 on the y-axis. Okay, now let's remember what we just said about the shape of the graph of cosine of x. It starts, the y value starts at +1, ends at +1, right in the middle, so that'd be when x is 0. You have a y value of -1. Halfway between that maximum and minimum value, so halfway between 0 and negative 3 pi, when you mark off negative 3 pi over 2 right here, we'll get an x-intercept. And halfway between 0 and 3 pi, so that'd be at 3 pi over 2, you get another x-intercept. So now graph looks something like this. So we've accounted for just the horizontal changes. This is the graph of cosine of x over 3 plus pi. Now we need to account for the 2 in front. So to obtain the graph of 2 cosine of x over 3 plus pi, all you do is multiply all your y coordinates times 2. So the y coordinate right here is 1 times 2 will give me 2. The y coordinate right here is 0 times 2 gives me 0. Down here the y coordinate is negative 1, so times 2 will give me negative 2. Here the y coordinate is 0, so times 2 gives me 0. Here the y coordinate is 1, so times 2 gives me positive 2. And now the graph is stretched, so it looks like that. There's the graph of 2 cosine of x over 3 plus pi. And I'll switch to a red pen now. Now I want to use that graph. Let me make it a little darker here so you know which graph I'm referring to. I'm going to take this graph of cosine and use it to sketch the graph of y equals 2 secant of x over 3 plus pi. Now let's remember that secant is the reciprocal of cosine. So let's just think about when cosine is 0. Now you remember from when we were graphing rational functions, when the denominator is 0, we often have a vertical asymptote. And that's what's going to happen here. Where cosine is 0, so at the x-intercepts, we get a vertical asymptote for the graph of secant. So the same deal at this x-intercept here. So I could even label the equation for the vertical asymptotes there as x equals negative 3 pi over 2 and x equals positive 3 pi over 2. Now the peaks and the valleys in your graph of cosine become the vertex for your sort of parabola shapes in the graph of secant. So they share those maximum and minimum values. As cosine gets bigger, as your denominator gets bigger, as cosine gets closer and closer to 0, secant gets bigger and bigger. It's going to go like this. Now down here cosine is negative as that value approaches 0. 1 over cosine gets very negative. These larger and larger negative values in your parabola point.